Welcome back to the Python programming series. This is part 2 video from module 2. String comparison. Strings are immutable. In and not in operators. Find function. These are all the topics covered in this video. Before starting this video, if you are new to explore electronics, then subscribe to it for more VTU syllabus explanations. Here the first topic is string comparison. Using comparison operator on strings. Here we have used comparison operator, that is equal to, not equal to, less than, greater than, less than or equal to, and greater than or equal to. These are all the operators we use to compare the two strings. Here strings can be compared using operators. Two strings can be compared using these comparison operators. Equality check. Here word is equal to banana. If word equal to banana, print yes, we have no bananas. It will check whether the string word is exactly the same as banana. Here the string word is exactly same as banana. That's why it will print yes, we have no bananas. Let us see one more example here. This is lexicographical dictionary order. Let us see with an example. Strings are compared like words in a dictionary, that is alphabetical order. Word is equal to apple. I have taken apple as a word. If word is less than banana, here dictionary order. Just remember this. It is compared in lexicographical order. If word is less than banana, print your word. The word is apple comes before banana. It will compare as a dictionary order. Else if word is greater than banana, if the word is greater than banana, something like cat, if I have taken cat, it is obviously greater than banana. Print your word cat comes after banana. Got it? Here it will compare in the dictionary order. That's why it will print as your word apple comes before faster. Comes before banana. If I have taken apple, it will print this statement because A comes before B. That's why this is the statement that will print. And else if word is greater than banana. If I have taken cat as a word, it will print this statement. Else print yes, we have no bananas. It will print this statement when these two conditions become false. Here the output is your word apple comes before banana. Here A will come before B. That's why this is the output we will get in this case. Your word apple comes before banana. Very clear with that example? Here string comparison is case sensitivity. Uppercase letters comes before lowercase letters in ASCII or Unicode. For example, word is equal to zebra. Here Z is uppercase. It is compared with banana. It will give the output as your word zebra comes before banana because the uppercase value comes before lowercase. Remember this. Whenever you get the uppercase in your string, it will come before the lowercase. Okay. Because Z is the uppercase has smaller ASCII value than B. The uppercase has smaller ASCII value than B. That's why it will come before word banana. Got it? Very clear? Fixing case sensitivity. You have to convert all strings to the same case before comparing. If word dot lower less than banana means I am converting that zebra to the lower case. Print word comes before banana. Here I am converting the word to the lowercase before and again I am printing the statement. This is how exactly you have to fix the case sensitivity. If you want to convert from lowercase to uppercase, here you have to use dot upper from lowercase to uppercase. Very clear? String comparison has some limitations. Let us see. Strings comparison works alphabetically. As I told you in the previous example, it will works alphabetically. but it doesn't understand the meanings. For example, zebra, banana, it doesn't understand the meaning of that word. Just it will take the alphabetical order. It doesn't understand what exactly the fruit meaning. Got it? The strings can be compared with normal comparison operators as I told you, equal to, not equal to, less than or equal to, greater than or equal to. These are all the comparison operator to compare the two strings. Order is lexicographical, that is dictionary order. Uppercase is always less than lowercase in comparing two strings. You have to take the uppercase before lowercase in comparisons. Because uppercase has lower ASCII value, that's why it will come before lowercase. And use dot lower or dot upper for case sensitive comparisons. You have to use dot lower to convert to lowercase, dot upper to convert to uppercase. Very clear with the string comparison? The next concept is strings are immutable. What is immutable? Immutable means it cannot be changed once created. You cannot modify a character inside a string directly. Let us see with an example. Greetings is equal to hello world. I have created a string that is greeting is equal to hello world. Greeting 0 is H here. I cannot change to J. If I want to change to J, it will show an error. And the output I will get as string object doesn't support item assignment. Because the strings cannot be changed in place. I have already created a string that is greeting is equal to hello world. I can change once after the creation of the string. If I want to change, I have to create one more string. Got it? I will explain you later that. The correct way is creating a new string. Let us see with an example. Instead of changing, build a new string using slicing and concatenation. Let us see. We use slicing and concatenation to create a new string. Let us see with an example. Greetings is equal to hello world. New greetings is equal to J plus greeting 1. In the first place, I am changing it to J, which means I am using here slicing as well string concatenation. Got it? Here print new greeting. I will get the output as Jello world. Why? Because I have changed the first place, that is H, to J. That's why it will get Jello world in the output. Original strings remains unchanged. Whenever I want to access the greeting, if I print the greeting, it will print the output as it is hello world. No change. Nothing will change in this greeting. It will remain same. New string is created with modifications. I have created a new string with some modifications. I have used slicing along with the concatenation here. You can see. In this case, I will get the output as Jello world. Very clear? Strings are read-only sequences. I cannot modify anything there. If I want to modify, I have to create a new string. Got it? Lists, however, are mutable. List can be changed. It can modify in place. In the case of list. Strings are immutable because the characters cannot be changed directly. To change, I have to create a new string using slicing and concatenation as I have explained in this example. That is hello to Jello. It is done by J and hello. That is concatenation and slicing. Next concept is in and not in operators. Let us see how exactly it will work in Python. In, it will check if the left argument is the part of right argument. For example, P in apple. P is there in apple, that's why it will return true. I in apple, it's not there in apple, that's why it will return false, like that. The left argument P, I, A, P, P, A, these are all. Here the left argument is a part of right argument, that is P, I, A, P and P are the left argument and apple is the right argument. Whether the left argument is a part of right argument or substring of the string. If it is there, then it will return true. If not, it will return false. Very clear, very simple, right? And edge cases, a string is a substring of itself. For example, apple in apple. It is a string is a substring of itself. It is true. A in A, it is true. The empty string is also a substring of a string. For example, I have taken empty string here. This is also a substring of the string. That's why it will return true. I have taken empty string. It is also substring of string apple. That's why it will return true. Got it? The empty string is a substring of any string. Any string, whatever you take, it will be substring of any string. Not in operator is opposite to in operator. X not in apple. Yes, that is true. P not in apple. False, because P is there in apple. It will return false. Completely opposite to the in operator. Very clear, right? Very simple as well. Let us see one more example here. Here the example is to remove the vowels from a string. Define remove vowels phrase. Here it will define a function to remove the vowels from the given text. Vowels is equal to AEIOU. Stores the vowels in variables, that is vowels. String sans vowels. It is creating the empty string to build the result. For letter in phrase, it loops through each character in the input. If letter dot lower not in vowels, it will convert to the lowercase to catch the uppercase vowels, and here it will add to the result string. Return string sans vowels. Here it will return the final string without vowels, that is print remove vowels hello world. Here in this hello world, it will remove the vowels and give the output as HLL WRLD. Clear? Here the letter lower ensures the uppercase vowels like A, E are also removed. The vowels in the uppercase are also removed by using this letter dot lower. Got it? And the next topic is find function. The purpose of the find function is it will return the index of the first occurrence of the character, a substring in a string. Which means if I take letter is equal to banana, find A. It will go and check the first occurrence, that is B, A. It will give 1. And if the character or substring is not found, it will return -1. If it is not found, it will return -1. That's it. Let us see with an example. Define my find haystack needle. Here we have to find and return the index of the needle in haystack. We have to find the index of the needle in haystack. Return -1 if needle doesn't occur in haystack. We have to return -1 if needle is not there in the haystack. Let us see. For index letter in enumerate haystack, in haystack, we are searching if letter is equal to needle, return index. If we found the needle, we have to return the index, or else we have to return -1. Let us see one more example, that is haystack is equal to banana rama. I have taken banana rama. Print haystack dot find A. I have told you first occurrence, which means it will found A, which is after banana. That's why it will return the index as 1. And print my find haystack A. It will check the A in the haystack. Here also the first index, that's why it will return 1. Both give the index of the first A, because I have told you the first occurrence. It will find the first occurrence of that string. Here the find function is opposite to indexing. Why? Because in find function it will give the index of the given character. In indexing it will give the character at the given index. Got it? These two are. Indexing means it will give the character at the given index. Find means it will give the index of the given character. Very clear? Return inside a loop. It will stop the loop immediately as soon as you find the string what you are looking for. This pattern is also called as Eureka traversal. Here string.find character is a built-in way to get the index. Using find function, I can easily access the index by using character. It will return -1 if it is not found. It is very efficient because it will stop whenever I get the element whichever I want. Here ends part 2 of module 2. In this video I have explained string comparison, strings are immutable, in and not in operators, find function. These are the topics I have covered in part 2 video. In part 3 I will cover the remaining topics in this module 2. Thank you very much for watching. Subscribe to Explore Electronics channel for more videos like this.